Bismillah ar-Rahman ar-Rahim. This is teacher Iman explaining some exercise about permutations and combinations. Let's start by question number 1. After reading, write true for the true statement and false for the false one. In number 1, we're going to say that if we have x permutation 3 equals to 7 times x minus 1 permutation 2, then we have to tell that x equals to 9. You have many ways to solve. The easiest one by using the ratio. And we have to think about this because we can see that we have here consecutive n and consecutive r. So let's divide them both by the smallest permutation, which is this one, x minus 1 permutation 2. Here also I will divide by x minus 1 permutation 2. That will allow me to cancel the same factor here with the same factor here. And I can see that I have consecutive factors here and there, like this exactly. X and x minus 1, 3 and 2. This is a rule, and this rule is saying like this. If you have n permutation r divided by n minus 1 permutation r minus 1, that will give you n. So I can get from here all x, and that all equals to 7 because 7 is left. And he told you x equals to 9, and this will make it false. In number 2, we're going to see that we have permutation for n and n equals to 720. We remember the rule which is saying n permutation n equals to n factorial. And he said f, so I need to use all what he gave me from here to there. 720 will be written as 6 factorial. I can cancel factorial from both sides to get n equals 6, not 7, and that will make it false. In number 3, we can say that n permutation n will give you 1. That means we're going to say either n permutation n equals to n factorial, or we can say that n permutation 0 will give you that one. So it is false again. In number 4, we can see that if we have x permutation 2 equals to 30, and this is given, then x equals to 6. We can start from the given by thinking about two factors consecutive to each other will give you 30. They are like this exactly, which are 6 times 5. So that will make it as x permutation or 6 permutation, because this is the biggest factor, permutation with 2. We can see that if r are equal, then these n's are equal to give you x equals 6, which make it true. In number 5, we're gonna have, if we have x permutation 2 equals to 72, we're gonna think similar by two factors. Start is by 9 times 8, and that will give you 72. So you can have now another permutation, which is 9 permutation 2. If we're going to see that the r's are equal, so we can equal also the n's. That will give you the value of x, which is 9, which is not similar to that one. That will make it false. In question 6, we can see that n permutation n minus 3 equals to 120 multiplied by n combination n minus 3. They have the same n and the same r, so that will allow us to use the triangle, which is exactly like this. N permutation r equals to n combination r multiplied by r factorial. By dividing by the smallest, and the smallest always the combination. So I can divide each by in combination n minus 3, and here in combination n minus 3. We can cancel these and make a ratio between these from here. That will give you r factorial. So our r here is exactly n minus 3. n minus 3 is our r. So n minus 3 with the factorial will be equals to 120, which gonna be 5 factorial. I can cancel factorial from here and there to get n minus 3 equals 5. Move negative 3 to the other side to get 5 plus 3, which is 8, which is different than the value here that make it false. In number 7, he said that if we have 7 is the smallest factor of 2n permutation n, then equals to 6. According to the rule of the smallest factor, we can say that n minus r plus 1 is the smallest factor. So this will be instead of n, this will be instead of r, then add 1, then equal it by 7, like this exactly. 2n minus n plus 1, that all equals to 7. By subtracting 2n minus n, you will get 1n, and move this one to the other side, you will get 6, which is the same as this, which is true. In 8, we have n permutation 0 plus n combination 0 plus 0 factorial. Each has a value. This has 1, the other has 1, the last has 1. If you add them all, you will get a 3, and that will make it true. In 9, we have x minus 1 permutation 2 equals to 2. That means we need to think about 2 factors will give you 2, which are 2. Here, x minus 1 permutation 2 can give you 2 at 2 permutation 2. Or you can equal now the r's together and equals n's together. That will give you x minus 1 equals 2. By moving negative 1 to the other side, x will be 3. You can use it in the other given because we have 2 givens. Y stays as it is, unknown, and the x will be replaced by 3. Here y stays as it is, and we're going to replace x by 3, multiplying 2 by 3, which is 6. I can add these together, and by down plus down equals up by saying y equals 3 plus 6. That will give you 9. Now we're going to have to subtract them. Y minus x should give you 9 minus 3, which is 6. The same as the question, which is true. In 10, we have this given, which is if we have 5 permutation r equals to 60 and another given, n factorial equals 120. You can see that we can start by the n, and you are lucky if he's gonna give you n, because you can start by it by writing 5, then 4 and multiply them, then 3. Then be sure that you will get 60. Yes, you are. 5 times 4 is 20. 20 times 3 is 60. So you got 3, or you have 3 factors, which are the number of r. So I can say that 5 permutation r is the same as 5 permutation of 3 at 60. Now r will be 3 exactly. In the other given, n factorial will be equals to 5 factorial, which can be n equals 5. Then I will replace instead of n and r in the combination. N is 5, r is 3. by using permutation, 5 permutation 3 over 3 factorial. Write 3 factors up, starting by 5, and the 3 factorials down. So that means we are going to write 5 times 4 times 3 divided by 3 times 2 times 1. You can cancel as possible the common of them, 3 and 2 for example, by getting 10, which is the same as his answer, which is true. In 11, we can have this given, which is in combination 6 equals in combination 4. If we have same n and different r, we can add down plus down to get up. So we can start by the first given, which is n equals 6 plus 4, then n equals 10. I can take this 10 to the second given here, which is 10 permutation r equals 720. Also, you are lucky if you have the value of n. So start by it by writing 10 multiplied by 9 multiplied by 8, and this is enough to give you 720. You can count them to know how many factors you have. You have 1, 2, 3 factors that will make this 10 permutation r the same as 10 permutation 3 at 720. That will make your r equals to 3. Then the last step is we're going to add them. N plus r equals n is 10 and r is 3. That will give you 13, and that will make it true. And equation 12, we can see that if we have x combination 3 equals to 12 and x, you can return it back to permutation if you would like to. That will make it x permutation 3 divided by 3 factorial equals to 12 with this x. By making cross multiplication, that will make your work easier. Like this. X permutation 3 stays equals to 12 multiplied by 6, and the x stays as it is. This is a multiplication, and this is x. Now you can get 72 multiplied by x and expand the left side by getting 3 factors here. Start is by x, then x minus 1, then x minus 2. You can cancel this x from the right side with x from the left side. And you will have 2 factors, and they are consecutive, written from the biggest x minus 1, then x minus 2, all equals to 72. And 72 can be written as also 2 consecutive factors, which are 9 times 8. Because you have 2 factors to the left equal to 2 factors to the right, and they all consecutive, you can equal one of the factors, the biggest with the biggest, or the second with the second, by getting x minus 1 equals to 9, and moving this negative 1 to the other side, you can get x equals to 10, which is true. Now at number 13, we can see that another given, which is in combination n minus 2 equals to 15. You can think about the reduction rule. In reduction rule, you know that in combination r can be written as in combination n minus r. Similar, if you have in combination n minus 2, it will be the same as n combination 2. Like this exactly. Focus on that up and that down, which is here exactly. You will have this r here, similar to that r here. This 2 here is similar to that 2 here. So I can simplify my work here to be in combination n minus 2 by reduction rule. It will be in combination 2, and this will give you 15. by using permutation, and permutation 2 over 2 factorial will give you 15. Do a cross multiplication like this exactly. Here you will get n permutation 2 equals 15 times 2, which is 30. And we can think about two factors consecutive to each other will give you 30, like 6 and 5. The biggest will be the value of n. So n is 6 now, which is not 9. So that will make it false. In 14, we're going to have this given, which is n minus 3 combination 5 equals to n minus 3 combination 7. According to the same n and different r, we are going to use the rule of equality by adding down plus down to get up. You will have n minus 3 equals 5 plus 7. You can add them to get 12. Move this negative to the other side. Change its sign to be 12 plus 3, and that will give you 15, which is the same as that, which is true. In 15, we can have 6 combination 3 equals to 5 permutation 2. He is asking you to prove that left-hand side is equal to the right-hand side, so you need to evaluate each alone. Left-hand side, including 6 combination 3, to evaluate it, return it back to 6 permutation 3 divided by 3 factorial, which gonna be 6 times 5 times 4 over 3 times 2 times 1. These together will be cancelled with the 6, and you will get a 20. And if you are going to solve for the right hand side, which is including 5 permutation 2, you will write 2 factors only, which are 5 times 4, which is going to give you 20. You can see that after comparing them, they are equal, so that will make them true. In 16, we have this given. In combination 5 equals to n combination 3, I can also add these two down plus down by the equality rule to get up. You can say that n equals 5 plus 3, which is 8. Now you need to replace n instead of n by 8 minus 8, which is 0, and 0 factorial will give you 1, which is true. In 17, you're going to have this given, which is n combination n minus 3 equals to 20. By reduction rule, you are going to write it as n combination 3. Like this, n combination 3 will give you 20. Return it back to permutation by n permutation 3 divided by 3 factorial equals 20. Make it over 1 and make cross multiplication. You can get n permutation 3 equals 20 times 6. N permutation 3 including 0, 6 times 2 is 12. Now you need to think about 3 factors will give you 120. They are n permutation 3 equals 6 times, from here, 5 times 4. 6 times 5 times 4. So the biggest is the 6, which is the value of n. So we got now the value of n, which is 6. And then you need to find its factorial. 6 factorial will be 720, not 120, which is false. In 18, we're gonna have, if we have the value of n permutation 0 is 1, and n combination 1 is n, equals to n plus 1. This means he wants you to tell for any n belongs to natural without 0, you will get the left side equal to the right side. we need to evaluate each. Here we will have 1 plus n, and in the other side we will have n plus 1, because plus is commutative, so they are equal, which is true. In 19 we have f means given 2x factorial equals 12 with x. The best way is you can cancel this 2 here and there by dividing both sides by 2 here and there. That will give you x factorial equals to 6nx. Expand that left side, which is, or you can divide both sides by x like this. You can say that x factorial divided by x will give you 6. You have a rule before, you can use it, saying if you have n factorial divided by n, that will give you n minus 1 factorial. So you can use it, or you can expand. So here you have x minus 1 factorial equals 6, which is 3 factorial. You can cancel factorial here and there to get x minus 1 equals to 3. Move this negative 1 to the other side. That will make x equals 4. He gave you another given, which is y combination 3 equals 10. You need to think about how many factors we have. We have 3 factors, so you can write it as y permutation 3 divided by 3 factorial equals 10. This is 3 factorials. By making cross multiplication will give you 60. So that will give you y permutation of 3 equals 6 times 10 is 60. Think about 3 factors will give you the 60. We can think about 5, then 4, then a 3. If you multiply these two, 5 times 4 will give you 20, multiplied by 3, which is 60. That means y will be 5 permutation 3. So we have y equals 5, we have x equals 4. I can do then, which is x plus y equals 4 plus 5, which is 9, not 10. That will make it false. In question 20, we're going to have n squared minus 4 and n squared minus 1 with n should equal to the right side, which is including the biggest factor, n plus 2, and 5 factors. Let's prove that from the left side. Do we have 5 factors? Yes, we can by expanding each. In the first one, I can use difference between two squares by writing n plus 2, then n plus 1, n minus 2, like this. In the second one, I can write n plus 1 and then n minus 1, which are the rules of difference between two squares. Then n is coming later. You can reorder them by starting by the biggest, n plus 2, then n plus 1, then n minus 1, then n minus 2. Like this. 2, 1, 0, negative 1, negative 2. The biggest is n plus 2, and we have 5 factors, which are like this. 1, 2, 3, 4, 5 factors. So we can write it in this way, which is similar to the same expression here. That will make it true. Thank you for listening.